Okay. state-of-the-art, open source state-of-the-art NLP. אנחנו הולכים לדבר על ה-Spark NLP project. מה הפרויקט, למה הוא טוב, למה הוא קיים, איך הוא עובד מול דברים אחרים, איך משתמשים בו, זאת אומרת, נראה כמה דוגמאות קוד. ומה צריך לעשות כדי להתחיל. אם יש שאלות, בבקשה פשוט תשאלו תוך כדי. Oh. Okay, is there anyone here who only speaks English? Oh, okay, so this will be in English. Okay, good question. Okay, so Spark NLP is an open source library that was started almost 3 years ago. And really because two things happened in the NLP space about 3 years ago. One of them was deep learning, okay, where almost overnight, most if not all of the state-of-the-art implementations, meaning kind of the best accuracy you can get, became dependent on deep learning implementations. So really almost overnight, most of the libraries we know and love, like Spacey and NLTK and Stanford NLP and all of those, became way behind in terms of the accuracy you can actually get on common tasks. That's one thing. The other thing that happened is really a lot of it is with the Spark, Apache Spark ecosystem. We found out that we could get, and I mean, I've been working on this for probably about 7 years in different kind of contexts in industry, and we found that we can get 1, 2, 3 orders of magnitudes of speed up over what was supposedly kind of really fast C implementations with kind of thin wrappers. And we were also able to scale this to multiple machines. So really there was this need to create a new library that from the outset would be built for speed and built for scale. And would implement some of those new implementations. And the focus here was not to have a library for research. The focus here was to have the kind of the production grade, trainable, scalable implementations of those projects. This is the most recent kind of O'Reilly research on AI in the enterprise. When they look mostly at practitioners, and this is from February this year, and this is kind of the main one we have, but there are other indications. Showing basically the Spark NLP is the most widely used NLP library in the enterprise setting. So we're very happy to see it. You see in terms of libraries, you have TensorFlow, Scikit-learn, Keras, PyTorch, and then Spark NLP in terms of use. And really what they said is that there was no library that became used by 16% of enterprises. This was in less than 2 years after it was first released. So really there's a significant need in the open source community and in the industry to actually have the ability to have things that are kind of production grade, ready to go, and actually utilize the latest advancements. In terms of accuracy, so this is one benchmark, just a very common task which is named entity recognition. This is EN core, LG, and this is average F1 score. There are many reasons for why this is more accurate. Okay, but of course, it's not just doing deep learning. It's you need to optimize the actual network, of course, right? And it's a question of kind of which paper are you implementing, how are you optimizing the network, how are you optimizing the implementation, right? So we're using kind of custom or contrib layer definitions. We implemented BERT embeddings. We tune BERT embeddings for specific cases, right? So there are kind of many optimizations, many more of them. Most of them are not at the data science level, the more the software engineering level, to make sure things actually work. So that's accuracy-wise. Speed-wise, so the library is based on Apache Spark. So we knew that, yes, this is basically the only library that kind of scales natively, can scale to any Apache Spark cluster. But then we also wanted it to be extremely fast on a single machine. Because a lot of NLP work and just a lot of data science, you start on a single machine, right, just on your local data. What we compared it with Spacey, and we compared it here on a really simple case, where we just want to train a sentence boundary detector, tokenizer, and POS. Okay, so no crazy deep learning games. And the goal was to see, look, can we be faster, right? Even though supposedly we have the overhead of the JVM and the overhead of Apache Spark, right? Versus something like Spacey, where what they say, look, this is like Cython, right? We have like really optimized nice C code and like a very thin wrapper. This was trained on really not just a single machine, like really a medium strength laptop, 16 GB memory, 4 cores. And on training, it was really 80 times faster. And there are two types of reasons for why this happens. Reason number one, we worked a whole lot on optimization, right? And we just did a whole lot of work on profiling ourselves with Databricks, with TensorFlow, everything from kind of the memory structure, JNI. We use RocksDB to load embeddings once, right? There's a whole lot of optimizations there. The other thing to understand is really what the Spark ecosystem did on optimizing work on single machines. How many people are familiar with the Project Tungsten and kind of the Spark level optimization? So just so you're aware, when you work with Apache Spark locally, you're not using the JVM kind of as, like not the 1990s JVM. So in the 1990s, when the Java memory model was defined, in Java, every string starts at 48 bytes. Okay, this is just the way it is. Okay, lots of references, lots of boxing. Right now, what Spark does, it does its own memory allocation. So it has its own malloc. It doesn't use a garbage collector. It does its own thing. It has its own memory model. Okay, it has specific optimizations for different types of cache, caching like L1, L2 cache within the machine. So there's a whole lot of profiling that goes to get you really much closer to kind of to bare metal performance. And we've kind of worked with them and optimized to make the most out of that. So there's a whole lot that you get really out of the box. And of course, in terms of scaling, so this is one example where it doesn't do training, it does inference. By the way, all of those graphs, they're public. There's 3 O'Reilly data blog posts. It's around 15 pages altogether. But the code is public. You're welcome to reproduce it and check and look at the numbers and the settings as you want. This benchmark took basically the previous example, just on inference, not on training, ran it with 0 code changes, and basically showed how we can scale nicely on a cluster and actually use multiple nodes. And this really just took the same code and ran it on AWS EMR. The trick, of course, is that we rely on Apache Spark to do the really, really hard things that you have to do when you distribute a system, right? So how do you minimize copying and memory copying? How do you minimize shuffling? How do you do execution planning? Right, and really the nice thing is like this is the core thing that Spark does for you, right? When you scale to a cluster, so basically we just leverage that ecosystem and that substantial effort that's already done, and then it's really just a case of really understanding kind of Spark in depth and being able to take advantage of what's there. Of course, when you scale. Like this is a nice example. Like it's nearly scaling on inference. That's cool. But of course, different algorithms scale differently, right? So if you're using something that's by nature iterative, right? Like if you're doing a CNN, right? It's iterative. Yes, you're not going to get linear performance when you scale. And when you're looking at many machines, when you're looking at hundreds of machines, definitely yes, you need to understand Spark configuration, right, and be able to optimize that. And that obviously does matter, right? So it's like it's not magic. It's software engineering. Other than that, another thing that's happened in the past 2-3 years is that the compute platform, like the chips, the processors that we can use are also not what they used to be. So we have GPUs who have obviously highly optimized instructions and libraries specifically to do large-scale matrix operations and other operations that are kind of common when you're building CNNs or RNNs. So that's from NVIDIA. Intel is also not said quietly, and also they've developed in their neon chips basically the same things, right? So they took kind of the most common instructions that are used in deep learning training and inference, and they've implemented at the optimized level, at the hardware level. So we have 2 builds that are specific to the latest NVIDIA and Intel chips. This benchmark that you've seen was run on AWS, and this was also training and NER and native recognizer in French. And we trained it. Basically, we wanted to test speed, right? So we said, okay, we need to get to the same level of accuracy, kind of with the same data. So we trained it, 80 epochs with a batch size of 512. And actually, what we are seeing now is Intel is actually doing better. Like this is fairly recent. This is from 3 months ago, and on the latest Intel chips, we see it's both faster and also substantially cheaper. Which obviously Intel have to see because NVIDIA I think still has the biggest mindshare by far. Okay, and really what we are seeing is it becomes a case study, a use case by use case thing on really what you should use both. From our perspective, from the library, really what we want to tell people, look, we do the builds, we do the optimization, we work with the company, you just take the version you need and run it and just it. You'll get the best that's possible at any given time, and that's that. So Spark NLP, everything I'm telling you today, it's not just open source, it's open source at an Apache 2 license, including the models, so the models are open source as well. It's a system that's widely used in production, and you have the link here, and you can look at the slides, they're online. Mostly, I mean, like, Amazon, Microsoft, Google, all of the major companies, I'd say, I think it's about like a third of the companies in kind of financial systems, insurance use it, and quite a few we have quite a few that we've worked with that are using it in production. One of the nice things is that if you use it within your environment, it will probably work out of the box. Because what we had to do, and this is, just I tell everyone, if you have an open source project, in the first year what you do is you just make it work in all the different environments. Right, so in the first year, what we had is we released it, and then someone tries it on SageMaker, someone tries it on Cloudera, someone tries it on their own, built Hadoop from scratch within secure environments, and then they tell you, oh, can you please add this configuration? Can you debug this? Can you enable this? All of this has happened. So now, whether you try it in Java, in Scala, in Python, in whatever environment, whatever format, whatever notebook, it's going to work out of the box, even in Windows. We've even done that. We release every other week. So like this year, we've had 27 releases already. So it's really every week or every other week, you get a new release with new code. And there's a very active Slack community. I think it's now several hundred people who are kind of on it. So that's a library. So next question, okay, is like, okay, it's nice, it's an NLP library, but what does it actually, what do you do with it? And there are some comparisons here, and this is I think, this was published by Domino Data Labs. Basically come and say, this is a full end-to-end NLP library from the very basic tasks, like, tokenizer, lemmatizer, stammer, part-of-speech tagger, right, to more kind of complete tasks like name and entity recognition, document classification, sentiment analysis, and such. The reason to make it an end-to-end library is because if you want to get the speed advantages, the caching, if you want to scale it, then you really need your entire NLP pipeline to be defined in the same way, right? So that you do zero copying of memory, right? So we use the Spark ML kind of pipeline model of adding columns, right? So that it scales natively, right? So there's no need to use other libraries. And at this point, we have kind of good coverage, basically all coverage of functionality. So that's there. And we'll see a couple of examples later in terms of text. In terms of where you can use it, so there's full APIs for Java, for Scala, and for Python. Okay, it's like 100% API equivalent in those three languages. And we have people who use them in those three languages, okay, which is nice because now, we know, I still give this example. We had, I think it was a few months ago, we did a new release and kind of we broke it on Databricks Cloud for whatever reason. Like within an hour, we had like 2 tickets coming, with people saying that they tried it, it doesn't work. We fixed it same day. That's a nice thing about having a nice active open source community. Basically, you do need to test everything. Even if you don't test, people will basically correct you same day. So, we're very happy to know, oh, it's like an hour later, people actually try this, use this, which is great. Other than that, of course, you have native support for both GPUs and the latest Intel chips. And native support for Spark, and if you do need big data, if you need S3 or HDFS, right, and actually have something that natively scales to a cluster, you have that out of the box. Okay, so Spark NLP is called Spark NLP because it is built on top of Apache Spark. Okay, meaning that every Spark NLP pipeline is a Spark ML pipeline. Who here is familiar with the Spark ML? Who has used it? Okay, so Spark ML has the concept of a pipeline. Okay, it's a class. The Spark NLP pipeline is the Spark ML pipeline. It's not even a derived class. It's exactly the same thing, meaning that it's very easy to reuse and mix Spark ML functionality and NLP functionality. So there's a couple of nice benefits we get. Okay, so one thing is that you can obviously unify your NLP and ML pipelines. So basically, you build one pipeline that reads the data, so you can read it in Spark and you can read it distributed already. You can do your NLP tasks, like extract entities. Then you can use those as features for, say, a machine learning pipeline. right? Also in the same distributed scalable caching, zero copying of data, same model. And then you can do grid search, hyperparameter optimization, cross-validation, whatever you need to finish your pipeline. All of that you do as one thing. It's less code, it's more elegant, it's serializable, and you get end-to-end execution planning, which is nice. The other thing, there are some things that Spark ML already does. Okay, so it does stopward detection, it does all of the kind of metrics, distance calculation, it even has TF-IDF, it does it has a distributed LDA implementation, so all of these you can just reuse, and we'll see examples, you can use it like kind of an exactly, it's very seamless. You'll see some code examples. Okay, so that's where it's built on top of that. So we use Spark under the hood. We also use TensorFlow under the hood, okay, to implement some of the deep learning aspects. The nice thing is when you use the library on a day-to-day basis, unless you really want to, you don't have to be aware of any of those. So if you want to, Spark is completely hidden, TensorFlow is completely hidden, and really with a few lines of code you can get things going. How many people here work with Python? Good. How many people work with Scala? Java? Yeah. So that's about the same distribution we see. See, but yeah, 80% Python and like 10% would be Java and Scala. And of course, all three of them care deeply about supporting for their stuff, which we do. Spark ML itself is written in Scala because one of the principles that we hit is that we want to run within the JVM, right? So PySpark is kind of an interface, right? They enable you to run Spark from Python, but your actual data, your actual Spark data frames are on a JVM, and we want all of the code to run within the JVM. We want to not copy data, okay? Because one of the biggest problems you have, if for example you use Spacey, right, within Spark, the point is that Spacey runs in Python, right? Your Spark data frames are on a JVM, okay? As a result, when you run a pipeline, most of what you're doing is you're copying strings in memory and you're doing inter-process communication. Okay, and you do a profiling, it's pretty ridiculous. Like 90% of it, like you actually do inter-process communication and copy strings in memory. If you're lucky, you're not actually, also reserializing and deserializing them. And that's really where the time goes. So Spark NLP itself is Scala, and then with PySpark, really, we have those pretty thin wrappers that enable you to use it. So here's an example of how you do sentiment analysis in English with pre-trained pipelines and pre-trained models. So you import Spark NLP. So and installing it's pip install, conda install. That's it. It's one-liners. From Spark NLP pre-trained, import pre-trained pipeline. You load your pipeline. So in this case, you load analyze sentiment ML in English. Okay, so you say I want to analyze sentiment with this specific machine learning model in English. And then you say, okay, pipeline don't annotate. Harry Potter is a great movie. You get a result, which is a regular Python dictionary. And then if you ask for the sentiment column or sentiment key from the result, it will be positive. Okay, so what this does, really simply, it starts a library. Spark.starts in the background. We'll talk about it. Start a Spark session. When you load the pipeline, close the pipeline, and everything else it needs. So pre-trained models, embeddings, rules, whatever may be the case, and then you just run it. Okay, but from your perspective, no TensorFlow, no Spark, nothing there. Who is familiar with name native recognition? Okay, so I'll explain what it is. Name native recognition is a very common NLP task where your goal is to recognize kind of semantically relevant entities from text. So in this example, we want to recognize people and places. So if we have a sentence like Chandler and Monica met in Central Park, then we want to know that Chandler is a person and not the city of Chandler, Arizona, right? So you can't use dictionaries. Monica is also a person and Central Park is a place. Okay, a good NER model, a good name native recognition model, specifically would not only rely on a dictionary. Okay, so for example, Central Park is not an actual place. Okay, but a good model should know that, look, in English, if you say someone and someone met in, after met in, you would only have either a time or a location. Okay, and this is not a time. Okay, it's a location, it's even, capitalized, so it should be obvious, right, even if you don't have it. Okay, so that's what an NER should do. And of course, this is a specific thing about people and locations. You may have another use case where you want to extract names of genes or diseases or corporations, right, or whatever you care about. Spark-built NLP comes with a pre-trained model. It actually leverages BERT embeddings and would give you the accuracy results that we saw a few slides ago. It's a pre-trained model, not just for English, also for, I think right now it's French, Italian, and German. And we're working on Spanish now. So we load the pre-trained pipeline. We have a pipeline object. Result equals pipeline.annotate. Harry Potter is a great movie again. And we have the results object, and which in this case would tell you that the first two tokens, so it would recognize Harry Potter as a person. Okay, so it would tokenize and then tell you that those two tokens are a person. Okay, which is really all you need here. One thing that I'm not showing here, but all of these pipelines are trainable. Okay, so if it comes to look, I don't care about people, right? I'm trying to extract, name of, products, right? Names of corporations, names of kind of my own, my own specific company's products because I'm analyzing, say, customer service calls, right, or financial products. Then you can train. Everything is trainable as well. Another thing that we have is a spell checker. And by spell checker, what I mean is something that takes a piece of text and just autocorrects it. Okay, and there are actually 3 implementations depending on what you actually need. And this is one example in English. So we load the pre-trained pipeline, spell check ML in English. Harry Potter is a great movie, and if you see great and movie are misspelled, okay, and you run it. So you annotate this specific sentence. You look at the result, and it will tokenize, and actually in this case, it would correctly correct great and movie. Okay, and of course, this is also trainable, right? Because this would work well in case where you trained it on a similar dictionary, right? And you have words where really there's only one way to correct it within this kind of grammatical context. Okay, but if you work within, say, a company context, so for example, if you're reading patent documents, if you're reading legal filings, you also want to train on specific jargon, right? So that it knows those words and it doesn't correct them because it's not familiar with them. And that's here as well. Okay, one other thing. The previous examples were in Python, this is in Scala. Okay, so just to show you how similar the API is. So the only difference in Scala is you use val pipeline equals, val result equals, and the print line is different. Okay, but it's the exact same API, it behaves the same way. Java is a bit more verbose, but also it's the exact same API and methods. Other than that, so right now there are about 25 pre-trained pipelines for 4 languages. But really the most important thing with the library is you can train your own. Because in reality, for every kind of real-world NLP project, you will need to train your own. You will need to train your whole pipeline and your own models. Okay, so sometimes you can start with the pre-trained stuff, but the really useful thing is the fact that you have a pipeline class. You can configure each and every stage. You can replace the tokenizer, replace the lemmatizer, try different spell checkers, try different embeddings, right? And all of these are just parameter calls to a method. Okay, you can train. You can run multiple experiments. You can even now track them with MLflow, right? And really, that's your feature engineering. Okay. So really, for your own project, wherever you're reading, medical records, legal documents, emails, you can annotate them, have kind of standards training data, and build your own models. So when we do, for example, NER, here's what actually happens with the code we've seen. So when you call Spark NLP.start, it actually starts a Spark session. Okay, so you can supply it an existing Spark session, or you can just create its own. When you call a pre-trained pipeline, it actually loads resources. There is a lot of code in the library to manage resources. So pre-trained models, you can load them for S3, you can load them locally, you can decide kind of how you want to version them and how you want to load them. As I mentioned, we use RocksDB to basically to keep especially large models, large embeddings in memory. So one of the practical problems that you're going to have, if you have a large pre-trained model or large pre-trained embeddings, they're going to be about 2 gigabytes. Okay, and if you have now 4 cores or 8 cores, you cannot load them 4 or 8 times because you'll get out of memory errors, right? So we built a kind of this shared read-only in-memory database, right? And dealt with the kind of with the race conditions and ability to share them. And that's read for you. So they are read and stored locally. We initialize TensorFlow if we actually do anything that's deep learning related, okay, like NER, like negation detection, like some of those capabilities. We load the necessary embedding, the necessary graphs. There are a pipeline has basically two interesting methods. It has annotate, which we have seen, which takes a string and runs the pipeline on it. The other method is called transform. Transform takes a Spark data frame. Okay, so if you need to, if you want to use the same code we've seen, but you say, no, I don't want to run it on a string. I have this, 10 terabyte thing on S3. Can you just run all of that? That's all the change you need. Just load it into a Spark data frame, and then you can run it that way. Okay, and you get not only the fact it would actually work, it would actually scale, right? Meaning if Spark loaded it and you loaded it on 50 machines in parallel, you're using the same execution planner, and actually it would annotate them on those 50 in parallel, right? Which is really nice. So the NER, whichever stages use deep learning, like for example, NER with BERT embedding, that would run on TensorFlow. One of the other, like the big underlying investments we done, it was actually run TensorFlow on the JVM. So TensorFlow has an undocumented GNI interface that has to connect with it from Java. So we've used that really just to prevent memory copying and inter-process communication. Okay, and that's, if you really are kind of need to mix kind of classic NLP, more linguistic style, with the more deep learning, networks, this is very, very significant in terms of both the amount of memory you'll need to work with and the performance you're going to see. Embeddings are converted, and right now, I think since it was written, right now the library supports 4 kinds of embeddings. So we have word embeddings, chunk embeddings, like entity embeddings, we have sentence embeddings, and we can do full document embeddings, and you can mix and match them from different stages in your pipelines. And the result object is just a plain on Python library. Okay, but the nice thing is, really, you don't need to know anything about Spark and TensorFlow, as you've seen. You don't need to import them. You don't need to understand what the data frame is. You definitely don't need to understand what the TensorFlow graph is or what embeddings are. You just get the results and the accuracy. Right? That was the point. A lot of what we do with the library is really just keep running after the state of the art. And the cool thing with NLP is that really the state of the art moves so quickly that when you say you're doing some, you are the state of the art in terms of accuracy. Like 4 to 8 weeks later, something better comes along. So we spend all our time reading the new papers and trying to reproduce them, and the things that do reproduce. Basically, our job is to productize them, right? So create the production grade, testable, trainable, scalable versions, and just make them freely available. And that's overall the library. Okay, and everything I show you, as I said, it's completely open source, Apache licensed, and that's really what people tend to use today. As I say, not in research, right? So there's some really good research-oriented libraries, but when people need things kind of implemented in industry, that's usually what they basically move to. If you want to try this, so a lot of the case studies we have are from industry. So these are some companies who have published, and these are all of these are linked to talks in conferences, more industry conferences, so Strata Data, Spark Summit, O'Reilly AI. Okay, in general, this is shown like we're less in academic conferences, but we do all the main NLP and deep learning tutorials in kind of the large industry conferences. And what's interesting here is that also these slides would be much less about the details of embeddings and measurements and metrics. They're much more about, okay, if you really need to do a project that analyzes patient data, right? Analyzes 200-page pension fund prospectus, those types of documents. Here's what you need to worry about, right? In terms of how do you combine it with OCR, how do you do data annotation correctly, right? What kind of NLP pipeline you need to build, right? How do you deal with biases and measurement issues, right? And really kind of how do you get those projects to actually run within the largest industry setting, right? And then I think most, if not all of them, have public notebooks that go with the talk. So kind of if you just want to run the code, that's there as well. If you want to try the library, it's pretty simple. So and you don't have to copy this because if you you Google Spark NLP, these come first. So nlp.johnsonlabs.com, and Johnson Labs, by the way, is just the company that's kind of supporting this and building this library. That has, they're getting started, so how to install, and it's a one-line install from PyPy, from Conda. If you're in Spark, it's within Spark packages. If you're on the JVM side, it's on Maven Central, right? So, and you have kind of the snippets to copy if you're in SBT or Maven. It has examples, right? Kind of code that you can take and copy paste. And it has a link to join, really important to join the Slack community. And many people, when they start, like you start, something, whatever, doesn't work, you don't understand the error message, you have a question. Like people, and you'll see these people ask questions daily, they get answered. And we are there as well from the development team. So it's a very friendly way kind of to get started. Another nice thing is if you go to the second link, so the workshop, so look up Spark NLP workshop. You have all the notebooks, you can just look at them on GitHub, but you also have a Docker container. So you just need to do you just do a pull and run, which takes you 5 minutes. And then what you get there is you get the library. You can get, within the Docker, you have everything you need, so it's kind of the right version of Spark and Jupyter and everything else. There are example notebooks, example data sets, right? So this is the easiest way to just come and say, okay, I do pull, I do run, you can actually like run something on your own notebook within like 5 minutes. Right, and a lot of the examples are there. So if you really try to do it, that's like the easiest kind of, within 5 minutes, actually see code and try it. That's what you would do. And of course, there's the repo itself. And we are always looking for contributors. So people ask me, what about Hebrew? So I say, well, the first person who contributes it will have Hebrew. We've done that with other languages. There's definitely, there's always things to add, right? And the nice thing about NLP, it's really an exciting time. Right, things are moving very, very quickly, and our goal is really to make it available as fast as possible, kind of to the industry, right? So that people don't need to, we are kind of there's the academia where yes, you need to solve this problem. For us, it's look once it's been solved, turn it into really easy to use 5 lines of code, but most importantly, actually works in production in large-scale systems, right? And make it available to people. So if you're interested in kind of contributing anything from just your own examples. Right? Oh, I solved this tricky thing. You need to use this parameter and just contribute your notebook. That would be amazing. And if you want to do more than that, also we'll be happy to talk. So thank you. That's all I have. Thank you very much. Ken. Yes. Yes.
Hi. Thanks for the talk.
Anytime.
I tried using this on NLP test a few months ago, and the amount of data I threw at it was too small to show any advantage versus space. It was just too slow in comparison. So, what would you say is the sweet spot in terms of amount of queries, amount of text that you're working with to justify to Spark and not make it seem so sluggish in comparison?
Yeah. So, by the way, so I'd say any problem, that's what you should do. So look, so first of all, this is what you should do. You should compare and see what works for you. I would say obviously that kind of really depends on the problem, right? We start like with a few hundred examples. We use it a lot for healthcare NLP. But then what you want, the question is how much are you really doing transfer learning, right? So how good are your embeddings, right? If you have really kind of large embeddings that are tuned, right? Really a few hundred examples, you will do better. Another example is really what use case you have, right? So if you're really just doing things on small scale, kind of on your own machine, and it's research, sure, you can use pretty much anything, right? So the question is really how do you need it to run, right? Going forward, and what environment do you need this to run? That's the second one. I would say, look, even within the library, there are different algorithms, right? So for example, even for NER, we have a CRF algorithm and a deep learning algorithm, right? Where the CRF algorithm it's not deep learning based, right? It gives you a higher accuracy out of the box, right? But it has a lower ceiling, right? So sometimes you say, yes, if you don't have enough data, just use the CRF one, right? Because the BERT one, it starts with loading 2 gigabytes into memory, right? So that's going to take some seconds, right? That's not a millisecond thing. Same thing with spell checking, right? We have 3 spell checking algorithms. Yeah, some of them are more rule-based, right? Because it comes to, look, I'm not going to train, right? Just show me what you have, right? And then, okay, fine, it does 60%, but it's better than what I had before. But I want to say, look, if you really have a large data set, you have like, 2 years worth of emails, just throw that into training, right? And training is going to take, minutes, right, on a cluster. But then, you're not going to be at 60%, you're going to be at, 75%, right? So yeah, definitely, there's a need for multiple algorithms and implementations. But it's really, just try it out. Yeah. Yes?
Has there been any consideration of doing transformer instead of the binary binary
So yes, so in NER we do that, in negation detection we do that, in entity resolution we do that. Definitely, yes. So we use BERT embedding, so we use, and now we're looking to other transformers, which will come out later this year. Look, right now for NER, it's not just BLSTM, it's BLSTM for tokens, CNNs for characters. Sometimes you need the CRF at the end, sometimes you don't, right? That's kind of something you want to experiment with, yeah. It's not just BLSTM anymore. It's not 2017, but yes. Other questions? Okay, so look, it's free, it's for you, give it a try, and really anything that's needed, here are my contact details. I'm always happy to know what people are doing and see if we can help. Thank you.